Okay, so today we're going to look at the last of these notes, which is percentage composition. Okay, so this is now where I give you the formula, like H2SO4, and I want you to tell me the percentage of each element based on its mass in the compound. So again, I've got steps, but this is really logical, girls. So let's just think about this. I actually hate teaching you steps. I hate you having to rely on steps because I would like you to think logically about these things, and but unfortunately it only comes with time, the logic, and that's what I'm trying to teach you is the logical thinking, and that is definitely what you learn from science. So if you think about what the steps are, so if you work out the total molar mass, so I've worked it out already over here. The total molar mass for H2SO4 is 98 grams per mole, okay? And now if you take the masses of each individual element, so we have hydrogen, sulfur, and oxygen. Let's say we had another oxygen next to the hydrogen, which is not going to happen in this compound, but imagine there was another oxygen here. You would add those two oxygens together, okay? So I would take H2, and it's good to write it out as it is in there so that you remember to make that when you look at the molar mass of the hydrogen, that you times it by 2, because in the compound you have 2 hydrogens. You have a sulfur, and we have 4 oxygens. So that does help you to work this out. So if we take a look and we go, okay, the molar mass for hydrogen is 1, but there are 2 of them. Okay, so I get 2. Molar mass for sulfur is 32. Okay, and there is only 1 of them. And then oxygen is 4 times 16, which gives you 64. Okay, so now we have each individual mass, and we've got the total mass. Now think logically, how are we going to get a percentage here? Well, if we take this mass of each individual element and divide it by our total times by 100, we're going to get a percentage. So if we divide by 98, okay, and don't forget to times by 100 because you do want it as a percentage. You can put percentage like that, hydrogen, so that you're telling me what you're doing, okay? It's important to set your work out nicely when you, especially for final exams, so that the people marking your paper know exactly what you're doing. Okay, so 2,04, you can go to 2 decimal places, yeah, it's really fun. And that would be a percent. Okay, this one divided by the 98. Now remember, we get the 98 from the total molar mass for the whole compound. Okay, times 100. Okay, so 32 divided by 98 times 100, and we get 32.65%. Now you can work out the last percentage by just taking 100 and minusing those two, but you want to check that your calculations are correct. So 64 divided by 98 times 100, and that is 65.31%. Okay, so if we add those together, so 2.04 plus 32.65 plus 65.31, we get exactly 100%. How cool is that? So all of that gives you 100%. Now, girls, it's not always going to give you exactly on the dot 100%, okay? It could be like 99.8 or 100.5. It's all to do with these rounding off values, okay? And also remember that your periodic tables values are also rounded off. So don't be worried if you're not exactly at 100. If you're close to 100, that's fine. If it works out that you're nowhere near 100, let's say it worked out that you added and you got 60 or something, then check your molar mass. Your total molar mass here could be wrong. So just bear that in mind. Okay, so let me do the rest of them so that you can see how to do this. So NaCl, the total is 58.5. calculate each element. So we've got percentage Na and percentage Cl. Oh, well, we're just working out the masses now, aren't we? Okay, so 23, and we have, oh, I don't know why I'm looking, I know what this is, 35.5. Okay, so for percentage, now we can do that. In A, it will be 23 over 58.5 times 100. Okay, so it's 23 divided by 58.5 times 100. And this is 39.32. Okay, Cl is equal to 35,5 divided by 58,5 times 100. 35.5 divided by 58.5 times 100. And we get 60,68. Okay, now you can see it's really close to 100. If you want to pause the video, you can and try this on your own and then see, carry on with this. That's perfectly fine. All right, so now we're looking, we've got N, we've got H. Now remember, careful here, we've got 2 N's actually because of that there. So 2 N's, we've got 8 H's because we've got 4 in there, but there are 2 of those parts. We've got 1 sulfur and we've got 4 oxygens. So let's just check with that. So we've got, one of these is 14, so we've got 28. This would be 8. Sulfur is 32, and this is again 64 because we have 4 oxygens at 16 each. Okay, then you are looking at percentage nitrogen, would be 28 over 132 times 100. Percentage hydrogen, 8 divided by 132 times 100. Percentage sulfur, 32 divided by 132 times 100. And it's actually nice to set it out like this so that I can see exactly what you're doing, and it's like in a logical order, so that you follow, that you are doing all your steps. Just bear in mind that sometimes people stop over here, and you forget to actually work out the percentage. I've seen that before. Times 100. Okay, 21.21%. Okay, 8 divided by 132 times 100. 6,06. And sulfur, 32 divided by 132 times 100. 24,24. And last one, 64 divided by 132 times 100. We get 48,48. It's funny how they are all recurring. All right, and let's just generally see if this is okay. 2, 2, 4, 4 with the 8. Yep, that looks pretty good. Okay. This one can be a bit complicated. So we've got K2Cr2O7. So the potassium is 39. What does it make? 78. Oh my gosh, I can't believe I can't do this. 78 is late, girls, and I'm exhausted. Okay, 52, so that is 104, and I won't do this one. 7 times 16 is 112. Okay, and now you just do all of that over again. So this time I'm actually just going to leave out all that working out, and I'm going to go 78 divided by 294. And I get, oh gosh, I thought this was weird. I forgot to times by 100. 26,53. Percentage chromium. 104 divided by 294 times 100, 35,37, and percentage oxygen 112 divided by 294 times 100, 38.0 or 38.1. Okay, so let's add them together. 38.1 plus 35.37 plus 26.53. Okay, and I'll end up with, like I said, you can get near 100. So this works out to be 100.9%. Okay, and that's because of the rounding off that we did over here. All right, so I hope you understand that. This one's pretty easy. After this section, we're going to start stoichiometry. Now, we're going to use all the mole stuff that we've done in this section to do that section. So please do think tank 4. I think I've given you the whole exercise because it's really not that much. All right, please let me know if you need me.